Let's look at another couple of examples related to the buoyancy force. Here we're just going to have like example 2 of the buoyancy force. We've got like a pontoon for construction work, has a mass of the 50 tons. A pontoon is a rectangular in plane, for example, in plan. So we have like in plan, we're just going to have like a rectangular with like the 10 meters length and 5 meters width. Okay, and size like a 2 meters. 2 meters side here is high, and the plan is like a 5 meters by 10 meters. So the density of the seawater, we're just gonna know that is, for example, is given to us like the 1025 kilograms per cubic meter. So the question here is to determine the volume of the water displaced by the pontoon. So this like the based on the buoyancy or on Archimedes principle. And B, we're just gonna need to just calculate or determine the depth of immersion and freeboard. And you know the depth of the immersion, we can easily calculate by using the formula, and vice versa, we can calculate the freeboard. And finally, we're just going to need to calculate the buoyancy force of the pontoon. The results are pretty simple and straightforward, just written here, so you can have a look and see what's going on. First of all, for floating body is the displaced water. We can easily calculate by using the formula. You can use like the W is equal to mg or rho gv, or you can just easily set that here. If we're just going to cancel out the g from the right and left hand side, we're just going to have like a v, or the volume of the displaced water is equal to the m divided by rho. Okay, so the rho can be just rearranged and comes to the left hand side. And we know the mass of the pontoon is like the 50 tons of the 50,000 kilograms. We're just going to use the metric units, like, and divided by a rho, which is like a 10.5. And the answer is like the 48.78 cubic meters. So this is the volume of the water displaced. So once we just have like the water volume displaced, we should be able to calculate the depth of immersion. The depth of immersion is simply calculated by dividing the volume of the displaced by the plan area. Plan area that we know is given to us 10 by 5. So 10 meters by 5 meters, if you're just going to divide that for this by this figure, we're just going to have like a 0.98 meters. So we know that the height is like a 2 meters, 2 meters taken away, and 0.98 taken away from 2 meters. We just kind of like the 1.02 meters freeboard. Imagine, let's say roughly rule of thumb, like the 1 meters. 1 meter is like the submerged, or like the depth of immersion, and 1 meter is like a freeboard, or like the accurate, like the 0.98 meters and 1.02 meters. And that's it. So the buoyancy force, section C, saying that, asking for to calculate the buoyancy force of the pontoon. You can just do the buoyancy force in 2 ways. The first way is that we know that like the buoyancy force is like the is equal to the like the force is equal to the mass of the body, or the mass of the pontoon. We can easily say like the mass of the pontoon, but because it's like to say like the what is the force, we need to just calculate it based on the newtons. So we need to just multiply the mass by the gravity acceleration 9.81, which is equal to 490.5 times 1,000, or 10 to the 3 newtons, or the kilonewtons, or 490.5 kilonewtons. Alternatively, you can use like the original formula of the buoyancy, which is equal to F is equal to like the rho GV, and rho is like a 10.25, G is like the 9.81, and V is the volume of the water displaced, which is like the 48, is given here, 48.78. So the result is the same, 490.5 thousand newtons or kilonewtons. Let's look at example, another example, example 3. We have like the situations, a pontoon unloaded, so there's no like the load on the top of the pontoon, being used in the river estuary to transport construction equipment, have a like the mass of the like a 50 tons with 8 meters long by 5 meters wide, has a like the sides of 1.5 meters high. So okay, the water is saline with a density of like a 1025 kilograms per cubic meter. So the question here is to calculate the depth of immersion for unloaded pontoon. Okay, so let's look at this like this example, how we're just going to go ahead with that one. So for example, section A is like more or less straightforward. We're just going to use the same formula, like the mass density is equal to like the the water of the volume displaced is equal to the mass divided by the rho. This is like the formula that we know is very straightforward. So the V is equal to M divided by rho, or we know, like, if you know the like the M is equal to rho V, if you just rearrange that one, you're just gonna get this one. And simply we can easily calculate the volume of the water displaced by divisions of the like the mass, which is like the 15 tons or 15,000 kilograms, divided by the rho, or the rho of the water, which is 1025. The volume of the water displaced is 14.63 cubic meters. Okay, so that's like the for the volume of the water displaced. But the question here is to calculate the depth of immersion. So depth of immersion is easily or simply calculated by the volume of the water displaced 14.63 divided by the plan area of the pontoon, which is 8 times 5. So the answer is like 0.37 meters. It's like the depth of immersion, or the depth of or height of the water under the water surface. Section B is asking about what weight can be carried by the pontoon while still maintaining a freeboard of the half a meter or 0.5 meters. Okay, if you have like a half a meters, and we know that like the side is like a 1.5, so we're just gonna see in that case we are allowed to just have like the minimum of the half a meter's freeboard. So in that case, we want to just have like a 1 meter under the water, or the depth of measure 1 meter. If we're just gonna do this one 1 meter, we can easily like doing like in the reverse situation to calculate the volume. For example, if you imagine this is like the 1 meter, we can easily calculate the volume water displaced, and the water from the water volume displaced, we can easily calculate the mass, the total mass, which is equal to the mass of the pontoon and mass of the weight that can be carried by this pontoon. Okay, let's just do this in reverse, like the cases. So if you like a freeboard is like a half a meter, we know the depth of immersion will be like the 1.5 minus half, which is a 1 meter, and with 1 meter volume of the water, the volume water displaced is equal to 1 meter times 8 times 5, which is equal to 40 cubic meters. So to 40 cubic meters, you can easily convert that one. And you know, if you arrange this formula, M is equal to rho V. If you have like the V, if you just multiply by the rho, we can easily calculate the M. So 40 meters is multiplied by the density, which is like the 1025, the density of the saline. The answer is like the 41 tons, okay, or like the 41,000 kilograms, which is equal to 41 tons. So once you're just going to have like the difference here, we can easily take away the mass of the pontoon, which is like the 15 tons. 15 tons taken away from the 41, the answer is like the 26 tons. So this 26 tons is the additional weight that we can just carry for this pontoon. And if you're just going to calculate this one in newtons, you know better that you need to just multiply by the gravity acceleration, 9.81. So the answer is like the 255.6 kilonewtons. Okay, you know how to write this one. Rather than kilonewtons, you can write like the 10 to the 3 newtons as well. This is the example, a couple of examples for the buoyancy force.